Hello, everyone. Hope you're all having a fantastic day. Good start to the weekend here. I'm recording this after school, so if there's an interruption on the intercom, I apologize. But today we're going to be talking about the derivative of log functions, logarithms. So first, this part is from pre-cal. It says, remember that the inverse of an exponential function is a logarithm. All right, the inverse of e is the natural log, so the inverse of an exponential is a logarithm. Kind of goes hand in hand there. So we've got the log of a to the x, log base a of x is y, and you remember you can rewrite that as a to the y power equals x. A to the y power equals x, and that is actually how we're going to set up and figure out our derivatives for logs. So what we're going to do is use this idea in this question, and this is the how we find logs, or this is why it works. I'm going to use this example and then give you a format, a formula, or format, whatever you want to call it, that you can follow every time you do this. So it says let y be the natural log of x, then e to the y equals x, right? If you e both sides, e here, then e to the y equals x. So let's find the derivative of that. The derivative of e to the y, this was on one of your assignments actually. The derivative of e to the y is e to the y times the derivative of y, which is dy dx. And the derivative of x is 1. So solve for dy dx, divide by e to the y, you get dy dx is 1 over e to the y. And again, what I'm showing you here is how we come up with our formula, how we come up with our rule. This is kind of like where it's derived from. So dy dx equals, and e to the y, we were told back up here, is x. E to the y equals x. This was our original formula, e to the y equals x. So what we're doing here, if that's the case, we could also say that y is the ln of x. So the derivative, d dx, the derivative with respect to x, of the natural log of x, in this case, if I plug the natural log in for y, is 1 over x. So that's kind of how we come up with the format. And here's the formula. We'll put a little asterisk by this thing. The derivative with respect to x of the natural log of u is equal to 1 over u du dx. Hang on one second. Should be unlocked.
The one that thought was coming back isn't coming.
Okay, that's fine. All right. So we have the derivative of the natural log of u equals 1 over u du dx. And this is the formula that you're going to use to solve derivatives of logarithms. We're going to deal mainly with natural logs for these first few sections, and then we'll talk regular logs in a little while. So, differentiate. We've got the natural log of x cubed plus 1. So first, I'm going to label u. U is x cubed plus 1. It's natural log of u. So du dx, 3x squared, plus 1 would be 0, so just 3x squared. All right, so the derivative, dy dx, is going to be 1 over x, in this case 1 over u, right? 1 over x cubed plus 1 times du dx, 3x squared. And then you know we can simplify that as 3x squared over x cubed plus 1. So not that difficult of a concept. We do, again, up here, 1 over u, 1 over u, 1 over our u value right here. This part is u times the derivative of u. Same thing down here. U is sine x. Let me go in a little bit here. So du dx is going to be cosine of x. So dy dx, the derivative of y with respect to x, 1 over u times du, which is going to be cosine x over sine x, which if you remember from pre-cal, if not from the beginning of the year, cosine over sine is cotangent. Yippee-ki-yay. So again, it's 1 over u du. So the principle is not that difficult. Example number 3 here, we have the square root of the natural log of x. So the first thing that I'm going to do is rewrite this as the natural log of x all to the 1/2 power. So now I've created a chain rule. So f prime of x here, we're going to bring down our 1/2, right? And then negative 1/2. The inside stays the same, and then times the derivative of the inside. Well, the natural log of x, from back here, the derivative of the natural log of x is 1 over x. So the derivative of the natural log of x, 1 over x. Right? Now, I still have du. If I call x u, then the derivative of this is still 1, so it's kind of understood that there's that 1 out there, because the derivative of u in this case is 1. So that's understood. And then from there, it's just a simplifying problem. All right, you got, let's see, 1 over 2 square root of ln x and times x, so we'll call it 2x. 2x square root of natural log x. I'm just kind of getting through these pretty quick here. Alright, differentiate y equals the natural log. Now this is going to be a pain in the neck to try and do as a derivative of this, because you'll have to do a chain rule, you'll have to do a quotient rule, it's going to be a mess. Instead of that, let's split up the natural log of x minus 1, and let's split this up using our rules for logs, minus the natural log of the square root of x minus 2. Alright, now this is going to be natural log of x minus 1 minus, now square root, let me do this over here, the square root of x minus 2 is x minus 2 to the 1/2 power. And you can actually drop that 1/2 down now, right? So we have 1/2 natural log of x minus 2. So using just a little bit of your laws for logarithms, you can simplify that out. And then it's a piece of cake. dy dx. The derivative of the first one here, it's 1 over u times the derivative of u, which is 1. So I'm going to put it here. We don't really need it, but I'm going to put it there for consistency. Minus. And then we've got your 1/2 is still here. 1/2 times 1 over u. Derivative, which is 1, so I'm going to put it here again. So dy dx is 1 over x minus 1 minus 1 over 2 times x, 2 times 2, 2x minus 4. And I'm not going to make you get common denominators and squish those together. Just leave that as it is. So again, I just broke it up. 1 over u, derivative of u, 1 over u, derivative of u. Same way every time. This one here says use the law of logs to help differentiate. So same thing I did up here, just now they're telling me to do it. So I'm going to split this thing up. First, I'm multiplying right here, so there will be an addition. I'm dividing here, so there will be a subtraction. So let's write this out here. F of x is the natural log of x plus the natural log of x squared plus 1 squared minus the natural log, the square root of 2x cubed minus 1. And to save me some space, I'm going to go ahead and write that as power of 1/2. Just like I always do. So all I did was split it up using my laws of logarithms. Anytime I'm multiplying through the top, put a plus sign between it, split it. Anything you're dividing by, put a minus sign. Alright, and then from here, f prime of x, and this helps me break it up. The natural log of x is 1 over x, and the derivative of x is 1, so that's not going to change anything. Plus, we can bring this 2 down, right? Bring this 2 down here, bring this 1/2 down here, so it'll be plus 2, 1 over u, times the derivative of u minus 1/2, 1 over u, times the derivative of u. Oh, squared. That's cubed, isn't it? 6x squared. Again, let me step aside here just for a second. The 2 comes down and it stays out front when we take a derivative because it's just a coefficient now. 1 over u du. 1 over u du. Process is the same over and over. So f prime of x, this will be 1 over x, and I'm just going to simplify these terms one time. 2 times 2x is 4x up top, plus 1, minus 6x squared over, this will be 4x cubed minus 2. Yep.
Emmanuel McLeod, if you're in the building, please step to the front office.
There it was. I knew it was coming.
McLeod.
Oh, he was a student of mine. Huh. The derivative of the natural log of x. Ooh, this one's good. Okay. All right, derivative of the natural log of the absolute value of x. Okay. To do derivatives of absolute values, if you will remember, the first thing we had to do was split it up into a piecewise. We have the natural log of x and the natural log of negative x. This is when x is greater than or equal to 0, when x is less than 0. Here's basically what you're looking at. You've got the absolute value. It's going to be something like this and this, roughly, just to give you an idea of what it looks like. So we take the derivative. Derivative of the natural log is 1 over x. Derivative of the natural log of negative x. Well, since we're dealing with the absolute value here, we're looking at 1 over x. And that's when x is greater than 0, x is less than 0. Remember, I drop the equal to sign when I take a derivative because this is a cusp, so it's not going to be equal here. Oh, that's 0. I'm sorry. It should look like this. Yeah, there we go. All right. Should come down like that, roughly. So the derivative, d dx, of the natural log of the absolute value of x is still 1 over x. Still works. And this is really what we're trying to get to there. So it still works. Have a good one.